Okay, so we're going to learn how do we write nuclear equations for alpha or beta decay. So number one, we're going to write the nuclear equation for the alpha decay of proactinium. So the first thing we're going to start with, we're just going to rewrite this symbol exactly how you see it. So we're going to write the 231 as the top number, 91 is the bottom number, and then PA is the symbol. Okay, and then these are going to decay. So what does it mean for this atom to decay? If something's decaying, what's it doing? Good, so it's like losing mass. It's going to break down. So we're going to draw the arrow. Okay, so it's going to like break apart. And then this time it's alpha decay. So that means it's going to lose one of those alpha particles. Okay, so if you look at your notes, look at what you wrote down for an alpha particle. What's the top number for the alpha particle? 4. What's the bottom number? 2. On this one, I'm going to use the alpha symbol, and then the next time I'll use the helium symbol just so you can see either or. Okay, so it's going to break down to an alpha particle and something else. Okay. For the moment, I'm just going to draw a blank line. Okay, so this one atom, it's going to break up into two things. So an alpha particle and another atom. So we have to figure out what that other atom is. Okay, the name of the game is it's got to be balanced. So you can think of this arrow kind of like your equal sign. So your mass number on the left side is going to have to equal your mass number on the right side. Okay. Your number of protons on the left side is going to have to equal your number of protons on the right side. Okay. So it would be like 4 plus this number has to equal 231. Okay. And then 2 plus this number has to equal 91. Okay. You kind of with me so far, just conceptually? Okay, so the easiest way to do that is to subtract. So what's 231 minus 4? Okay, so we're going to write 227 as our top number. And then what's 91 minus 2? Okay, so 89 is the bottom number. And then now 89 is going to identify the element. So if you look at your periodic table, what element is number 89? And you can just give me the symbol if you would like. AC. Okay, so then we're going to write AC. All right, so what this means is proactinium, it's going to break apart into two things. So an alpha particle and then actinium. And then finally, to check your work, the left side has to equal the right side. Okay, so 4 plus 227, what does that equal? 231. Okay. And then we have 2 plus 89. What does that equal? 91. Okay, so you have to make sure the left side and the right side balance. Okay, let's take a look at number 2. We're going to write an equation for the beta decay of francium. And you're just going to start with this symbol. So you're just going to rewrite it exactly how you see this. And then all of these are going to always decay, so it's always the arrow comes next. And this time it's beta decay. So look at your notes for what you wrote down for a beta particle. For the beta particle, what's the top number?
0.
Okay. What's the bottom number? And I'm going to use the B or the beta symbol for this one, and the next time I'll use the E. Okay, so francium, it's going to break apart into a beta particle and a whole nother element, so we have to figure out what that other element is. Okay. Same thing, the left side has to be equal to the right side, so the easiest thing to do is just take this number and subtract this number. So what's 223 minus 0? Still 223. And then this time it's 87 minus negative 1. Okay, so remember if you're minus negative 1, you're adding it. So 88. And then if you use your periodic table, what element is 88? or symbol? Okay, radium or Ra. And then finally, check your work. Make sure your left side numbers equal your right side. Okay, so 0 plus 223 equals 223. And then -1 plus 88 equals 87. Good. Does that make sense? How, like, make sure both sides balance? Good. Okay, let's look at number 3. We're going to write the nuclear equation for the alpha decay of samarium. So again, we're just going to start. We're just rewriting this symbol exactly how you see it. All right, what's the next thing you write? Arrow? Okay. And then what kind of decay is samarium going to undergo? Okay, alpha. So what kind of particle will it produce? Alpha decay is going to produce an alpha particle. So that's 4, 2. And then this time, instead of the alpha, I'm going to write the helium, just so you can see an alternative way to write it. Okay. And then what's 149 minus 4? Okay, so 145. And what is 62 minus 2? 60. And then if you look at the periodic table, what element is 60? Nd. Good. Okay, number 4. We're going to write a nuclear equation for the beta decay of PM, promethium. So again, we're just going to rewrite that symbol. And then this time, what kind of decay is happening? Beta, so you're going to produce a beta particle. And that's the same thing as an electron, so this time we're just going to use E for electron, so you can see just the other way to write it. And then now, what's 165 minus 0? 165. What about 61 minus -1? 62. And then what element is number 62? Okay, SM. Good. Okay, try number 5 on your own, and then we'll check answers in like a minute. Okay, so number 5, what kind of decay is happening? Alpha, so what kind of particle is produced? Still alpha, right? Okay, do you want me to use the alpha or the helium? Helium. Okay, if you use the alpha symbol, is that also okay? Totally fine. Okay, and then 249 minus 4. 245. And 101 minus 2. 99. And what element's 99? Good. ES.